In this video, we're going to be learning about another way of traversing trees called breadth first search. So depth first search visits the tree from top to bottom. Breadth first search visits the tree horizontally. So it visits all of the nodes in a particular row first, and then it moves on to the row below. This is a tree. It's a directed graph of nodes, and each node has pointers to the next node. And if we were to do a breadth first search on this tree, the first thing we would do is visit A, then we would visit each of A's children, which would be B and C. And you can see we're visiting the tree row by row, we're just moving along the rows. Then finally, the next one we're going to visit is D, then we're going to visit E, F, and G. So how do we implement a breadth first search? It's really similar to how we implement a depth first search. The only difference is the underlying data structure is called a queue as opposed to a stack. So what is a queue? A queue is a first in, first out data structure. So everything that is added to the queue, as we see here, will be popped from the queue in the order that it arrived. So breadth first search is one that some people find difficult to implement, but let's see how it works with the queue underneath. So the first thing we're going to do is we're going to add A to our queue. So we start with a queue with just A on it. Now we pop A off the queue, and that means we're visiting A. So now A has turned blue because we've just visited it. As part of that process of visiting A, we're going to add A's children to the queue. So we're going to add B and C to the queue, and you can see those in the queue now. So this is all going to take place in a loop. So now we finished the first iteration, we're going to loop again, and we're going to remove the first item from the queue. So this is B. So we're going to visit B. So we visited B, and we're going to add B's children to the queue. So that's D and E. So now our queue has 3 items on it. So we loop again, and we're going to pop C off the queue. We're going to visit C, and we're going to add C's children to the queue. Once again, pop the top of the queue off. And we're going to visit that node, which is D. D has no children, so we don't add any more items to our queue. We visit E, which is the top of the queue. We visit F, and we visit G. And now our queue is empty, so our breadth first search is complete. So the code for a breadth first search is really similar to a depth first search, except the only difference is we use a queue instead of a stack. So we see here we have our queue. To represent a queue, I'm using a Python list. So we append nodes onto the list. That would be the queue.add operation. So you can see here we have our loop. We pop the item that's at the front of the queue. We print it out. We add the children of that node onto the queue. And that's exactly what was happening in the diagram that we just saw. So now let's do a breadth first search in Python. Let's run that code. If we run this, you can see the nodes were visited A, B, C, D, E, F, and G, just like this. Then that's exactly what we thought was going to happen, because if we look at our tree, you can see if we go horizontally from left to right, the first one is A, then B, and then C, and then D, E, F, and G. And that's exactly the order that they were printed out in our code. So that's the bell icon so you get notified when new videos are uploaded. But that's it for this video, and I'll see you next time.